What's going on, gentlemen? I thought I'd make a quick video covering blower motors. Not worried so much about condenser motors. They are what they are. Most of them are split capacitor motors. You get an occasional ECM type condenser fan motor, not as common. Blower motors are kind of a big issue. Troubleshooting them, figuring out what's wrong with them. Is it the motor, or is it a control board, is it capacitor, things like that. So this is a little box. I'll go through that in a minute. This is where I kind of keep some other test equipment stored, but what I want to talk about is blower motors. You've got your PSC, permanent split capacitor motors. You've got your X13 motors. Both of those are more of a constant torque type motor. ECM, we'll say X13. X13 motors are not variable speed motors. They can be installed in a system that maybe has a control board or something along those lines that will energize a different speed in a different mode, but they're not variable speed motors. Those are separate. You've got your 16-pin variable speed motors, and you've got your serial port motors that you kind of will find in communicating systems like the Train XVs, some Infinity units from Carrier, things like that. And I'll give you a link as far as websites you can go to as far as troubleshooting train equipment, communicating equipment, things like that towards the end of the video. But I really wanted to cover some things about blower motors. You've got your permanent split capacitor motors, which basically, everybody knows those. If you open it up, there's a capacitor, it's a PSC motor. Troubleshooting those is fairly simple. Usually the motor is either locked or seized, it's shorted, you got an open winding, or you got a bad capacitor on it. PSC motors have different speeds. You're going to have your common or your neutral, depending on whether it's 115 or 230. Then you're going to have medium or low, medium, or low. Sometimes it's low, medium, high, and high. Sometimes you just have low, medium, and high speeds. So when you're troubleshooting those, you check your capacitor. Maybe your capacitor is okay. It's a 5, a 7.5, a 10. Capacitor is checking okay. Motor's still not running. You can ohm out your windings. See if you have an open winding. See if your motor's hot. Typically, if it's locked or seized, you're going to have a hot motor. You're going to have a high amp draw. It's going to be trying to pull amps, but it's not running. Ohming out the windings on those, checking those typically. Sometimes your wiring diagram, you can't read it. Maybe it's some kind of aftermarket motor that's been put in it. Somewhere along the lines, you're trying to figure out which speed is which speed. So when you're trying to check a PSC motor and you're checking your speeds on a PSC motor, typically you're going to ohm out between whether it's 115 or 230 volt motor, your neutral or your common, and you're going to ohm that against each one of your speed wires. Your low speed is going to give you a high ohms. Your high speed is going to give you a low ohm. And any speed in the middle will give you something obviously in the middle. So just as a broad number, we'll just say you check your ohms on that motor, and from you get one winding giving you common or neutral to your speed, you're getting a 4. Then maybe another wire is giving you 2 ohms, another one's giving you 1 ohms. Your low ohm will be your high speed. Your high ohm will be your low speed. So just keep that in mind. Amp draws on those. Lower speeds are going to give you a lower amp draw. Higher speed is going to give you a higher amp draw. And what you have to keep in mind with these motors, they're not designed to overcome airflow restrictions like a variable speed motor or a serial port motor. So if you were to have an airflow restriction, maybe you restrict your return air, squeeze your return duct, you got a collapsed return duct, something causing any kind of a static problem, your amp draws are going to be low, your airflow is going to be low. So airflow restrictions on a PSC motor, basically your amps are going to drop and your airflow is going to drop. They're not designed to overcome airflow restrictions. So if you've got a dirty filter, maybe you've got a partially collapsed return duct, it'll spin faster, but there's not any air available, and that's why it's going to spin faster. It's going to ramp up, but it's not going to produce any CFMs, any extra CFMs. So you may have 1,000 CFMs on a PSC motor running properly. You restrict the airflow on it, it may only give you 700, 600, 750, 800, so it's going to drop in airflow. Where variable speed motors and serial port motors are designed to ramp up, which in that case is why it's important on those motors, variable speed type motors, check your static airflow on a system, especially if you're replacing one, because you can put in a brand new high efficiency system, but if your duct system's not properly sized and you've got airflow restrictions and you've got problems, that motor is actually going to ramp up higher to try to overcome that. And the adverse effect of that situation is that motor is now going to use more power, more watts. It's going to actually use more electricity, and their power bill can actually go up, even though you gave them a new high efficiency, more efficient system. So it's real important that if you're installing a piece of equipment that comes with a variable speed motor, you really want to confirm your static on your duct system is good, it's sized properly, because their light bill can actually go up. That motor is going to use more power. So X13 motors are similar to PSC motors in that effect. They're not going to ramp up, they're not going to give you more airflow to try to overcome that problem, and they kind of operate at the same constant torque design as a PSC motor. So what's going to happen is with an X13 motor, it's not variable speed. You may have a control board, like I said, that'll energize a different speed tap, but the motor itself is not variable speed. What you have to understand is all the capacitors, the relays, and the controls are all internal to that motor. So you're not going to have a blower relay in that system. You're not going to have a capacitor in it. It's all internal to the motor. So you have to keep that in mind. They're fairly easy to troubleshoot, especially X13s. You're going to have two plugs typically that go to an X13 motor. It's going to be the one that supplies your ground, your neutral or your common, and your line voltage, and then it's going to have a low voltage common. They're going to be on one plug. Then your other plug will be 1, 2, 3, 4, or 5. They'll be your speed taps and your low voltage control from the unit when you energize G or some train, or the carriers actually, carrier ICP products will have a circuit board in it that'll have a speed out wire or speed tap wire that will energize that 24 volts over to that motor. Typically you'll see two wires plugged to it if it's not a plug harness. Maybe one's plugged to 2, one's plugged to 4. One's going to be your heat pump or your cooling or your AC airflow. Another one's going to be your heat airflow. So keep that in mind. But if you go to an X13 motor in an air handler or a furnace and you run it, the airflow is not happening, blower's not coming on, the quickest way to troubleshoot that is typically to just go to your wires, go to your harnesses, confirm that you do have your 115 volts if it's a furnace, or your 240 volts if it's an air handler supplying that motor, because that motor is constantly powered with high voltage. It's just waiting for a low voltage signal to energize the relay to run it in whatever speed you're asking for, or whatever is your wiring diagram, whatever you're doing on that motor, however it's set up to run, what speed, what airflow, for whether it's a cooling mode or a heat mode. So you want to keep that in mind. So typically you want to check one. If you go to it and it's rocking and it's in there shaking, then typically you've got high voltage, you've got low voltage going to that motor. It's going to be the motor or the module. Sometimes you can replace the module, sometimes you need the whole motor. X13 motors just require a 24 volt signal. Close a relay internal to it, it comes on and runs in the requested speed depending on what tap you're plugged to on your low voltage side. If you get to it and it's not running, nothing at all, the motor's not hot, nothing's happening, you want to confirm that you've got your high voltage, and you want to confirm that whichever speed tap you're calling for is getting the 24 volt call to close the relay internal to the motor to ask it to run in that particular speed. Like I said, if it's shaking, you've got your high voltage, you're getting your low voltage. If you're sitting in there rocking, then you've got a bad motor. You need to replace the motor, you need to replace the module. Depends on whether it's warranty or not warranty. It's kind of how I handle that. US Motors, I love their X13. It's called an Easy 13 rescue motor. It's universal 115 volt and 230 volt. There's going to be a little place on the side where you'll open a door, and it comes with a plug pin. It comes out of the box ready for 230 volts. If you insert that plug pin that's in the bag, and now it changes that motor to a 115 volt motor, so you can use it in a furnace or you can use it in an air handler. When you put that motor in, you plug everything in, make sure you've got the plug set for whether you've got an air handler package unit, that's going to be 230 volts, or you have a furnace, 115 volts. And you're going to put that motor in. When you power it up, it's going to do a test run. It's going to self-determine which rotation, clockwise or counterclockwise. So when you put it in, put the door on, because it needs the proper static to set itself up. Put the door on, power it up. It's going to come on. It's going to run in one direction for about maybe 10 seconds. It'll run in the opposite direction for about 10 seconds. It'll determine based on the static which direction it needs to run, and then it'll lock itself in and it'll run in that direction. Every time I've used one, it's worked exactly as they say it does every single time. It's a good economical replacement. If the unit's under warranty, I'm going to try to get the OEM warranty motor, because they're not going to cover that. If you put an X13 in it, they're not going to, or the Easy 13, that won't work. So I do recommend keeping one of those motors. They're not very expensive. I mean, a couple $100, $230, $240, but I keep one as a rescue motor that I'm always going to use in an emergency situation. Weekends, it's cold, maybe it's hot, and you kids, elderly people in the house, you can put that motor in temporarily till you can get back with the OEM if it's under warranty. Get them some heating, get them some cooling, and then I take that motor back out, put it back in the box, and I can reuse it in another situation if I need to as an emergency motor. If it's weekdays, I'll go get the motor I need, come back and put it in. That's kind of how that works. Your variable speed motors, you've got your 16-pin motor and you've got your serial port motor. There's ways to troubleshoot a 16-pin motor. You're not seeing a lot of them anymore. You can use a 9-volt battery. You can go online and they show you how to troubleshoot those. But they're kind of, you don't see a lot of them anymore. I don't. Most of them are going to be your serial port communicating motors at this point. Train uses those. Carrier uses those. The serial port motors basically have a data package that goes back and forth between the board and the motor. You're going to have an RX and a TX terminal, or receive and a transmit. The email or the website link that I'm going to give you, which is for the train anyway, fieldtechhelp.com. fieldtechhelp.com. They have a lot of videos on there how to troubleshoot the TAM air handlers, doing the go or no-go test on the motors, checking with your DC voltage that you're getting the proper DC voltage for communications, and how to check to see if you're getting your data package sent from the board to the motor, and if that data package is being received back to the board from the motor. You'll check that. You're trying to determine is my control board not communicating with the motor? Is the motor not communicating with the control board? So you can go there and find those videos. But you've got to be kind of familiar with your different types of variable speeds, your constant torque motors, PSC, X13 motors. But one quick tool that you can get, I use the Universal Zebra motor tester. I've got that. You can pick these up, they're about $80, $90. This will allow you to tie in to your 24 volt common and your hot. You need 24 volts to power the speeds requested in the motor. You can get a connector that will go to an X13 type motor. You can get a connector that goes to a 16-pin type motor. and then you can get a connector that'll go to your serial port motor, but I don't trust that because that's communicating. There's specific ways you need to troubleshoot that. But once you get everything tied in and connected, each one of these adapters tells you how to operate this thing. But you can go in here and you can actually energize your different speeds for your motors. Fan on, fan off. When you're connected to your low voltage, this light will come on, and then you can run your fan, you can run your different heat speeds and your different cooling speeds, and you can actually test that motor, determine whether you've got a problem with the motor itself, the control board. In the instance of the 16 pin, typically, especially with Train, there's going to be a separate ECM or your X13 blower control board that the opposite end of this plug is going to be connected to, and then that board is going to energize and send signals for that variable speed motor to ramp up and down. So this is a good tool to have. You can get the TechMate Pro. This is an older version, just comes with the 16 pin adapter for the 16 pin variable speed motors. I have that, but basically it's just kind of an on and off, whereas with this I can run different speeds: high, low, medium, cooling speeds, heating speeds, fan, constant airflow for your continuous fan, and it'll test that motor, determine whether you've got your board problem, whether you've got a module problem. And as far as the variable speed motors and X13 motors, you can ohm those out, remove your module, ohm out your windings. Typically all your windings, when you go between everything, it's going to ohm out at 0.8, 0.9 on all selections, regardless of whether you're doing low to high to medium coming back around. You're going to have the same ohms. So once you've determined your motor is good, if your motor is not hot and you don't have open windings and everything's ohming correctly in the motor and that wheel's spinning free, the motor's probably okay. You can just go with a module, not a problem. But this is a good tester, gives you multiple applications, and based on what type of motor you're trying to test, you can get the different adapters that'll connect directly to this, and you can run everything that you're trying to test. So that is the Zebra Pro Universal ECM Motor Troubleshooter. That thing comes in handy. I've used it for a long time, and it's worked every single time. As far as what else I keep in this little box, keep a spare meter. I've got the Top Test gas leak detector. We'll turn that on. I keep a spare manometer in here. I keep a mega ohm meter in here. Keep a digital psychrometer, which, if you've seen the field piece job link set with your air probes and your temperature clamps and your transducers, those air probes do the same thing this does, but this is kind of a good backup. Keep a CO detector, UEI, carbon monoxide detector in the house, just to check if I have heat exchanger issues, things like that. But this Top Tease is about $20 on Amazon. Real quick test with that I want to show you. As soon as it warms up, it's got about a half a minute warm-up period. This is a lighter. I'm not going to light it. I'm just going to simply open a little bit of the gas to it. So that thing works well. I've tested it on my LP tank for my grill. It works. I've tested it by cracking a valve on a natural gas valve in a furnace. Just a little bit. It works great. So that thing's actually worked pretty good for checking for gas leaks. Always confirm it. You know, put you some spray bubbles on there and check that. But as far as motors go, get you a Universal Zebra, a Universal ECM motor troubleshooter. Those things work good. And just be aware of the different motors you're checking, whether it's a PSC motor, if it's an X13 motor, or if it's a true variable speed motor. They're all going to be a little bit different. But field tech, if you're working on a lot of Train equipment, the new TAM air handlers, PSC motors are going away. So most everything's going to come now with an X13 or some type of variable speed serial port type motor communicating with Train equipment. So if you work on TAM air handlers, go to fieldtechhelp.com, fieldtechhelp.com, and They have actual videos showing you how to troubleshoot their serial port motors, like I was telling you. Checking your data packages. Is the board transmitting that data package? Is it receiving that data package back from the motor? The go, no-go test. How to jump those terminals with 24 volts in common. There's a plug on the board. It's got 4 wires. There's 2 of those terminals you'll go between with 24 volts. The motor should come on and run. That's how you check to verify that the motor is good. Now you're going to narrow it down. Is the module on that motor, is it receiving the data package from the board, and is it transmitting back to the board from the motor? That's the key to troubleshooting the Trane serial port motors. The Infinity motors are very similar. X13 motors, obviously, you're just looking for your high voltage being present. Are you getting your low voltage call for whatever speed that's being requested or set up for that particular motor? The serial port motors are pretty much in the ECM 16, the 16-pin variable speed. Your serial port motors, your X13 motors, they always have high voltage present at the motors. They're always getting power, whether it's 115 volts or 240 volts. They're just waiting for either that communications on the serial port motor to happen for it to run, or they're waiting for a 24 volt call on your 16-pin motors or your X13 motors to run in the requested speed. So just keep those things in mind. There are plenty of videos on actually how to troubleshoot those. Maybe I'll get some of those motors together and actually cover it with a meter and go through it. But a good tool to have is this Universal Zebra ECM motor tester. It does the X13s, it does the 16 pins and the serial ports. If I'm not mistaken, you can get a version of this tester that also has that included as well. So it's one tool that can basically check all your motors, with the exception of your PSCs. And those are pretty common sense motors. Either you got a bad capacitor, that motor's locked and seized, you got an open winding, one or the other. That's typically what you're going to find on those PSC motors. So anyway, thought I would do a quick video on that. Hope you guys enjoyed it. Enjoy your weekends, and we'll see you sometime next week with another video.